and cosine in a little bit in your geo, but even if it's not, it's totally fine, okay? So a couple of things in the beginning. A lot of things that we've been discussing were applicable for the right triangle, but for law of sines and law of cosines are not only limited to right triangle. So these formulated principles are applicable for any kind of triangle, right? Okay, so in-person class, and we have enough time, and then I usually enjoy explaining how this principles came up. It's really interesting, but since we don't have that luxury, and I would just give you this upfront, right? So law of sine is nothing but the ratio, but it's not only the ratios with the sine of the sides and the angles. It involves with the value of sine function with the given angle. And just to remind you guys of this, if you forgot, and if there's triangle, it looks like this, then the way that you name the triangle is you give the letters for all three angles. And let's say we name this angle is uppercase A, and then the second angle uppercase B, and the third angle uppercase C, right? Then we call this one as triangle ABC. Then the names for each side will be according to the way that we name the angles. That for the position of the angle named uppercase A, the opposite side here is the lowercase a. So that means if the angle B is positioned here and the side B will be the opposite there, then angle C, uppercase C, is positioned there, and the lowercase c that indicates the side in opposite direction will be there, right? So this is how we can name triangle, right? So with this situation, angle uppercase ABC, and according the naming side ABC there, then no matter what kind of triangle that you're given with, this ratio always works. And you don't have to use all three ratio. As long as you have one firm ratio, then utilize that ratio to find the missing sides or missing angle. So you can utilize these two or these two or these two. So if you are missing either the angle or the side, and it's enough information for you guys to find it. Then from now on, you will see the instruction, it says solve a triangle. So the idea of solving triangle means you're gonna given with triangle, missing angles or sides. So there's gonna be some kind of measurement that is not given altogether. Then utilize these laws, then you should be able to find the missing ones. That's what it means, right? Okay, then let's see what kind of cases for us to utilize this law of sines to solve the given triangle here. So there's three cases. AAS is called triangle that comes with two angles and one adjacent side. So the side given has to be adjacent to either of the angles. In the case ASA will be you're given with the two angle measures, and the side that included will be given. Then there's a case SSA, that means you're given with two sides and then one angle. But this case is especially called ambiguous case, right? But I think within this unit, and it's not really heavily focused on this case, because this ambiguous case should be investigated all possible ways, right? But within the situation, we would not be able to focus that much on this ambiguous case. So as long as you are capable to find the solutions, the missing measurement, whether the upper two cases, and then you're good to go. And before we actually jump into this problem solving, and there's a couple of things that you need to know. This is what I just explained. The way that we name the angles and according the sides where the position the opposite, it's just upper cases represent the angle, and then the opposite position of the side will be just same letter but lower cases, right? And another thing, so within this section or the whole unit, we used to focus more on radian measures. So your calculator might have been set with the radian measures, but most of the problems given within the unit is mainly degrees. So if you don't set your calculator properly based on the context of each problem, you might get like really off numbers. So you have to make sure what angle measure setting that you need to solve the specific given problem. Okay, so those two things. Okay, then let's take a look at example number 1. So now, this is a typical case for us to utilize the law of sine to solve the given triangle. So given triangle ABC, the angle measure A is 70 degrees. Angle measure B is 80 degrees. And there is one side that goes with the angle A, because it's a side A, measured 12 centimeters. So this is the AAS case. Then we're supposed to find the other angle, angle C, and to the other sides, side B and C. So the first step that you need to do is you come up with the diagram of the given information here. And again, before you jump right into this problem solving, double check your calculator setting, okay? So if you are ready with your calculator and paper and everything, and you can go through the steps simultaneously while I'm doing to just check if your calculator setting is correctly, and then you can get the right values, okay? So first, draw the given triangle and make sure your calculator setting goes with the degree measure, okay? Then what could be the diagram for this? So it doesn't have to be right triangle. I mean, it is not right triangle at all. It's just two given angles already take up like 150. So one of the possible diagrams should look like this. An angle A measured 70 and angle B measured 80. And the other angle should be named C. Then if angle ABC positioned that way, inside A should be opposite from A, and then this must be 12 centimeters. So now this is simply the given information, right? Then here, since we have angle A and side A as given measures, we can definitely use that pair to utilize sine, law of sine. But here, since we are given with the two angles, And it's not that hard to find the angle C measure because it's 70 plus 80 is 150. And the leftover possible angle measure within triangle should make a 180. So it gives us the angle measure C is 30. So that's easy. So this must be 30. Then the setup with the law of sine with the situation with this pair here will be this. So now 12, the side on top, and then be careful, this is not just 70 degree by itself, it's a sine value of 70 degree. Has to keep the same ratio with the missing side, let's say with the B, then it has to keep the ratio with the sine value of the angle 80 there, right? Then you can simply apply the cross multiply over these two fractions with the equal sign. Then 12 times sine of 80 is B times sine of 70. Then now this is the missing variable. Then you divide both sides by sine of 70. Then B should be approximately 12.6. So it could be like 12.57 and blah, blah, blah. And probably each problem will give you clear information for the rounding. So probably it will say just round your answer to 10, right? So it's originally 0.57 and then it could be round to 0.6. So if you tried step by step with me simultaneously, you should be able to get similar approximation here. Then your calculator setting is correct. Okay, so now we know B is 12.6, right? So the next step, so angle C is 30 and side B is 12.6, and then only thing left with us is side C. So then now we have two pairs, angles and side relationship here, A and B and B. So it doesn't really make a big difference, but probably it's better for us to rely on the original information that was accurately given, because 12.6 is approximation after all, as you remember, right? So then for side C, the fixed ratio for us to utilize is still 12 over sine 70, right? Then we can have sine 30 and side C as the other ratio, and then it's gonna look like this. So 12 and then sine 70, and C is the missing, and then sine 30 there, right? Then it's the same step. You isolate the variable C there. Then this calculation, as long as you type everything, you punch everything carefully with parentheses or just enter each step and done according to the order of operation, and then it should give you 6.4. Okay, then another thing. So we are using this like A over sine of the angle A, and then B over sine of angle B, and then C over sine of angle C. But as you see, they are the ratio after all, right? So sometimes you have sine A over A, right? So it's upside down. But as long as all the other ratio follows the same format, so then it's gonna be sine C over C, and then sine B over B. Oh, it cannot be uppercase, so lowercase b. Then it works as well, right? Because they're ratio, as long as you keep sine value of the each angle on numerator side and the measure of each side on the denominator side, and then it's either 1 or 2, doesn't matter. And also it has to be, the pair. You cannot just have the one ratio with sine value of angle B and side measure of side C would not work, okay? Okay, any questions so far? Good. Okay. Then law of sine is just pretty simple. Okay, then let's move on. Law of cosine. So now we have everything found. Then we are done with the solving the given triangle ABC there, okay? So now it's the law of cosine. Okay, so there is a lot of prep. Then now you see each step, it shows how you separate the parts of the given triangle. So when you revisit these notes, when I upload it, and make sure you go through step by step, the animation, and then you should be able to understand how they came up with the law of cosine. And I usually enjoy showing all these steps in class, but as I said before, we'll skip now, but it's still gonna include, it's still gonna be included on the notes that I will upload this afternoon. So if you are interested, and then just go through the step by step and then try to make sense out of it. It's very interesting. So as a conclusion, if we see how it came up, how it come up, and then this is the principle of law of cosine that we are utilizing. That means the square of one side can be formulated with the square of the other two sides, the sum of the other two sides squared, and then subtracted by 2 times of the product of the other two sides times cosine value of the corresponding angle C. So only the one side will work like this? No, it's all three. So there's gonna be 2 more formula, follows exactly the same structure than if you are following the a square and then the other two sides are side B and side C. And then if you have B square, then it's gonna be a square plus c square minus 2ac in cosine. It's a corresponding the cosine, the angle B, and so on, right? So you will have all three following the exact same structure, right? So if you have triangle ABC there, 3 of the set of the law of cosine applicable for the given triangle is this. You start from side C squared, and then it's going to be a squared plus b squared minus 2ac cosine of the corresponding angle C. And b squared, so b squared right here, and then the other two are a and c, and then the corresponding angle is b, and then it follows this. And the other side, a squared, will follow this format. So then, when do we get to use law of cosine instead of law of sine. And it's pretty much no-brainer if we just think about the cases here. SAS means you have a side and an angle and then another side. Then in this case, it's impossible for us to use law of sine because there's no pair that it comes with the side and corresponding angle measure. Then it's impossible for us to have the starting fixed ratio with the side measure and the sine value of the given angle, right? Then what about this case? If you have only 3 side measures given, then in this case, there's no fixed ratio for us to use one side and corresponding angle measure for the sine. We cannot use the sine, law of sine. And there's another case. If you're only given with all 3 angles, again, there's no ratio that we can initiate the law of sines, right? Then these 3 cases are simply logically force us to use the other law, which is law of cosine. So the earlier 3 cases, we definitely can use law of sine, and then we can go ahead and find the missing angles or sides. But these 3 cases, there's no way for us to initiate with the law of sines, then we have to use law of cosine. So it's just either one or the other, right? So then let's take a look at example number 2 for law of cosine, okay? Then solve a triangle. That means we have to find the missing measures. And 2 sides are given. Side B is 1, side C is 3, and one of the angle A is 80. So in this case, we cannot use law of sine, so we will try law of cosine here. So draw a picture. An angle A is 80, and side C is 3, side B is 1. Then this is SAS case, so we are forced to use law of cosine instead. Then since we are missing the measure of A, then we should be able to utilize the law of sine with A squared. So A squared is B squared plus C squared minus 2BC times cosine with angle A. So if we plug the number correctly, and then it's gonna be 1 squared plus 3 squared, and then minus 2 times 1 times 3, and then cosine of A, 80. So this must be the equation for us to calculate. But in order to do this, again, you have to be really careful to get the right order of operation out of the calculator, okay? Because it involves like subtraction and everything. You either hit the enter button every single step, or you have to utilize the parentheses properly. So if you go through the right calculation, you should be able to get approximation of the side A is 2.99. So it's about the same length, but it's a little bit shorter. Okay, Then now, at least we know the measure of A here. So measure of A, side A was 2.99. Then what's left? We have to find the angle measure B and C here. So then, how can we find the angle? So now I have angle measure of A and the side measure, even if it's approximation, and we do know that. So once you have angle and the opposite side, then we can go back to the law of sine, and then we can find the angle measure here. So again, now we have the sine values of the angle on top. So sine of AD over the side A, 2.99, will be maintain the ratio of sine of C over the side 3. Then cross multiply, we will have this equation. But remember, what we isolate is not just directly the angle measure C, it's sine value of the angle C. So sine C is 0.9881 and blah, blah, blah. So then here comes the trick. Since we know sine of C is this value, what you can do is you use the inverse function on your calculator and then you plug this value there. Then you should be able to finally get the angle measure C. So here, the angle measure that we are finding, if that was supposed to be rounded to 100, and we can get 81.15 there. So then angle C is 81.15. Then angle B is easy. Utilize the fact triangle has 180 as a sum of the angles. Then if you subtract it from 180, then it should be 18.85. Then we have all three angles and sides. So the key that we have to remember here is this inverse function there. Okay, so that was the first example here.